This is actually our last week of class. Seems to have gone pretty quickly. I do have a poll up, so if you're just joining, go ahead and chime in terms of what you want for Christmas. I have received a bunch of project status review memos and lab day 3s, both that I'll collect and save and reply to and then grade, but probably not today, as has been the case so far this semester. I spend Tuesday and Thursday editing the video and processing it and uploading it and getting it ready for you guys. All right, so we are looking at this chapter 11, inheritance. Okay, inheritance. This is where we stop, because if you're on the live call, I ran it and it runs fine as a point of sale. But one of the things I wanted to show you was loading images and how to get image loading to work, and it didn't work the way it was supposed to. So I did fix it, and I posted an update to point of sale 3 on Canvas. So hopefully, if you guys were curious about how to do that and wanted to learn how to do that, you found that on Canvas. Let me stop the poll just to get it out of my way. The clear winner is the Lego pirate ship playset, and that is a fun playset. It is a pretty good choice. Okay, so I want to show you the point of sale 3 working. We had talked about all these changes that we made to pizza. We added the product image, we added the integer status code, we added the string special request code, and then support for that was rolled into point of sale 3. Although I don't really do anything with the status code at this point. All right, you guys should see mainly my Eclipse window, and I've got Pizzeria point of sale 3 up. And again, this is the fixed version, the one that I posted on Canvas for you guys to use. Let me run it just to show you what it does, and then we can peek at the code and see if you have any questions. Okay, it's still a pretty simple UI, and again, it still uses the simplification that it's going to add random pizzas. It does use a JList so that we can select individual items in the cart, say, to add, for instance, a special request, which you can type in, and then it'll show up associated with that pizza in the JList. We can remove pizzas. We can try to remove a pizza when we don't have anything selected, and we'll get this error pop up. So I used 2 images to give you examples of each, but I used the red pirate ship image essentially as a generic pizza restaurant image, and then if we were doing something with pizzas, then I used the pepperoni pizza image from the chapter. For place order, I used the pirate ship again, but for special requests, I used the pizza, since we're only selling pizzas at this point, and it was easy to add. So the app uses image icons. It also uses number format, which is something we've been using for a few chapters now, but I hadn't rolled into this specific example, so I went ahead and rolled it in so that we got good-looking numbers that were rounded, well. I load pirate ship red. The pizza is essentially unchanged, although I did add number format to it as well, so that when it returns or tries to display the pizza price, it is formatted correctly. And then Pirate Pizza adds the pizza image to it. So the Pirate Pizza, that was one of its additions, is that it gets a product image. So it's also an image icon, and it loads it as part of the constructor. I don't load the pirate ship image in pizza because it's not a pizza image. That red pirate ship image is meant to be a logo for the restaurant at this point. So it doesn't belong in pizza or pirate pizza. It belongs with the point of sale. All right. So the images get placed into the J option pane as one of the arguments for J option pane. There are different J option panes. You guys might remember, for instance, this one's an input dialog for the special request, and it takes different parameters when you show the input dialog versus if you just look right down here right below on lines 161, the message dialog takes a different set of parameters. You might get enough of a hint from Eclipse when it gives you the autofill kind of options. I seem to never do. I always have to look up what exactly are the options to get an input dialog to work correctly with, with an image. But anyway, this gives you an example of both syntaxes and adding images and using images. And so back to inheritance, and I know I've said this before, but some people get confused because they look at the code and they say, well, Pirate Pizza is so simple, and Pirate Pizza doesn't seem to have the price attribute. It seems to be missing. It's missing the crust style attribute. It's missing all of the stuff that we had previously coded in. So why did I skip it? And well, I skipped it because I used inheritance. Pirate Pizza inherited all non-private class members from pizza. So it gets price, it gets crust style, it gets toppings, it gets size, it gets all that as part of its inheritance. Not only do we not need to recode it, but we would not want to recode it unless we were specifically trying to override or replace one of those class members in the superclass with something different in the subclass. Otherwise, if we're happy with the choices we made in the pizza class, then we're done. We just inherit everything from all of our prior work from pizza and then add on to it in Pirate Pizza. Like we did in the homework check 3. You follow along if you did that. Most people did, but we had the ship class, which defined kind of generic ships, and then we had the pirate ship subclass, which added features to the ship to make it to help us turn this into a game-like app. So, but again, you don't need to redeclare anything that's in the superclass. If it's in the superclass and it's declared the way you want it in the subclass, and it's not private, then you get it and you're done. This is the syntax we were just talking about. I think it's actually clearer in the code itself, since I have more room and don't have to squish it up. Screenshot of what we just ran. Although, again, I didn't have that particular icon working. When I wrote this initially, I just had the icon working in one place, and then I'm not even sure why it didn't work. It should have worked in that place. I recoded it and fixed it, and then I went ahead and added the icon there as well. The keyword super we've talked about. The keyword super allows us to access class members in the superclass directly, which may seem a little bit weird since we get all this stuff in the subclass. Why would we need to access something in the superclass? And it's most typically used for overriding a method in the superclass with a new one in the subclass, but as part of the new one in the subclass, we also want to run the old one in the superclass. So we can run that method directly and then use those results in the subclass. It's a big chapter, not a huge chapter. Actually, it's a pretty averagely sized chapter, I guess. I have it as 32 keynote slides. And certainly we've had bigger chapters, and if you've peeked ahead to chapter 15, money and financial calculations, you might have noticed that it's also quite large. This concludes chapter 11, and you should have lots of options now, or lots of examples, of apps that create custom classes that do stuff for us, and then take the next step and use inheritance to make them better. So this is where I want to get to today, by the way, which is potential solutions. But we're going to start obviously at the beginning. To some extent, I feel like I've kind of teased you guys during the semester about this topic, or certainly in the textbook. Lots of times I say, hey, this is not the way we actually should be doing this, but we'll get to the chapter on this topic in chapter 15 later in the semester. And so to some extent, I've always tried to simplify money math and formatting money results to make it easy, and instead focus on basic coding fundamentals rather than the specifics of how do we handle money. That said, I have worked in a lot of the material on how to handle money earlier in the semester, but there's still more to learn, and I think obviously it's a core topic for business programmers. If you're going to be a business programmer, or you're going into the field, the MIS field, and you're going to be managing or directing teams of programmers maybe, or participating in a development process of some sort, you want to have a firm grasp of what the issues are in terms of calculations and money, and getting correct calculations, correct results storing correct results, moving forward with correct results as much as possible. And it's not a topic that's frequently covered either in computer science courses or in MIS programming courses for some reason. I think it's an important topic, an essential topic, and mastering some of this, being aware of some of it and being able to do some of it, I think will serve you in good stead in the future. As a bit of a recap, remember, cast your minds back to chapter 6. We talked about calculations and said that essentially calculations with decimal numbers should be thought of as probably really close approximations. The computer can only store as many bits of information as it has, so 64, 128. So you can't store every possible number with perfect accuracy. And when you start doing math then on numbers of imperfect accuracy, then you get imperfect results carrying forward. That said, in lots of cases, these are more than close enough. You get something, some of the numbers we'll look at today in a bit will look like, certainly they're more than close enough for any business that you might be able to think of. So what's the big deal? I'll also try to address that more heads on. And obviously there's a general rule that writing code that ends up losing your company money is probably a bad career move. So you want to try to avoid that. Where do these errors come from? We talked about a lot of this in chapter 6, but not all of it. First off, number one, what I just talked about, you can't necessarily store every possible number in base 10. Some of them are repeating non-finite numbers. Some base 10 numbers, same thing, like a third, you can't really represent with perfect accuracy. And then rounding, there's actually 4, only 3 would fit on the slide. 3 is rounding may not work the way you expect it to. This is not something we've talked about really in detail before, but there are actually different ways you can round numbers. And it's not that there's one correct way, but when you have a number that ends in a 5, for instance, you have to decide, do I round that up or do I round that down? And both are not quite right. Actually, the way you're supposed to round money is using a technique called half even, or this is also called banker's rounding. And half even will round in the direction of the closest even number. So as an example of, if you look at this number, 2.545, and you wanted to round it to 2 decimal places, it ends in a 5, so you have to decide, do I round that up? If I rounded that up, the digit to the left would be a 5, and 5's not even. If I rounded it down, the number to the left would be a 4, which is even. So using half even rounding, 2.545 would be rounded to 2.54 and not 2.55. And most of us learned in most math classes to round up always at 0.5. And so it looks weird if you see a calculation like that with money, and it doesn't appear to be rounding in the direction you kind of intuitively thought it should have rounded, then you need to ask yourself, maybe they're using banker's rounding. Did it round to the nearest even number? And if so, then actually they did it right. Number 4, mistakes involving integer math, which we've run into since early in the semester. When you do, for instance, integer division, you don't get decimal places as a result. You need to be really careful when using integers in any math, including math that's dealing with monetary amounts. And obviously, if you're super unlucky, you can have errors in your code which have more than one of these issues. So a quick scenario and then a more detailed scenario. So this is adapted from an example. I think Sun created it initially, but I found it also on the Oracle website. And one of their developers had this example that was kind of like this, so I adapted it for our pizza restaurant. So let's say we're out to dinner at our our awful pirate themed pizza restaurant. There's 6 people in total, so you're with 5 other people. You can think of it as 3 couples or whatever you want, but you order the $5 mini pizza. which is one of our promotions that's been pretty successful. And you want to add a 20% tip, and then you want to split the bill 3 ways. So that's the scenario. 6 people, $5 mini pizzas, 20% tip, split the bill 3 ways. If you're already doing this, in your head, it's not super tough math, but let's look at the calculations. So if you enter the calculations using double math, it might look like this. So we've got a double value for the bill. I've just called it bill. And so it's 5 times 6, which is $5 for each mini pizza times 6. I've tacked on the point zeros here, which I wouldn't normally do in writing these, but I just want to be really clear about what data types are, because that's part of the problem, is the lack of clarity sometimes with respect to the data types that we're working with. So I wrote it out as 5.0 times 6.0. And then I'm adding 20%, that's the gratuity. So there are different ways to write this, but I wrote it as bill plus 0.2 times bill to add the 20% gratuity. And I've got what you should expect the number results out to be in here as comments. So 6 mini pizzas at $5 each should be 30 bucks. The 20% gratuity then should get us to $36. Splitting the check 3 ways should be $12 for each couple. So we should see, if we output this, so I split the check here by dividing by 3, and then I just use system.println to output it, and you would expect that we'll see $12. If you can do that kind of math in your head, I assume you also got the $12. Each couple should owe $12. If you do this in Java, you get this. And it's really, really, really close to $12. Certainly if we truncated it, it would be 12. If we rounded it using any rounding technique at all, it would round to 12. This isn't even an issue where you have to worry about, are we using bankers rounding? Are we using, half even rounding? It doesn't matter, because these are just zeros, and it would round to 12. So maybe part of you that thinks, well, that's close enough. What on earth is the big deal? Yes, I see that it's wrong, but it's wrong by so little, and in a practical sense, it's not really wrong, because when we take the next step, which would be rounding or formatting, we can present it as $12 easily, and it's not going to trip us up. There's a bit of a tangent here, which is formatting money, but we already covered this earlier in the semester, because I added it in, when I thought we were ready for it. So formatting that 12 using number format would look something like this, and absolutely this 0.000, however many O's that is, 2, will not appear as part of that $12. The point I want to make is this bottom sentence. It's a but it's a big but. Even though we formatted it using number format, and even though we presented it as $12 in the UI, we didn't change the variable. The variable still holds that 12 point, all those zeros and 2. And so that inaccuracy still exists, and it will get stored, maybe written to a database, maybe pulled up later as part of, the end of the day receipts. And so we did not make number format, the way we're using it, does not make that inaccuracy go away. In some ways, I mean, you might even think it's a little bit worse, because it looks like it does. What we see on screen, the result of number format is going to look rounded correctly. It's going to look like the right result, and we might not be, completely realizing that, but wait a minute, we didn't change the stored value. We didn't change what was stored in the variable. We just presented it in a way that was correct. So keep that in mind. And everything we do, you have to ask yourself, did I actually change the number, or am I simply presenting a variation of it that's correct? But let's take the next step then. I mean, I saw that and I thought, yeah, that is a nice example of this, but it is so close. You know, maybe there's some way to create a similar type of business scenario that actually will trip us up. Okay, you know, in reading, we tend to think that computers are perfectly accurate. That's right. That's kind of their thing. Is they do all this math and they do it so quickly and they do it perfectly and completely consistently, and that's why they're wonderful. But then that's not entirely true. Here's an example that will be a little bit more impactful in that these are actually numbers, bad numbers that will make their way onto a receipt. And I don't know if you guys have ever gotten receipts with numbers like that. Anyway, once you start looking for it, you may notice, I guess it depends how many receipts you come across in a given month, but every couple of months you may notice, hey, this receipt has actually got an error on it. It's not right. Anyway, that's a bit of a tangent. The Add a Parrot for a Penny special. So our terrible Pirate Pizzeria, Captain Jack Parrot's Pirate Pizzeria, has this promotion, Add a Parrot for a Penny. And it's because pirates love to alliterate, obviously, and there are lots of P's in that. And we have too many parrots in the restaurant. We bought them in bulk, and it turns out they're actually messy and loud and kind of mean, and we're trying to get rid of them. So, but for $5 and a penny, you'll get the mini pizza along with the 10% discount on your order, and the diners get sent home with a fun-loving, hygienic, quiet, easy-to-care-for pet in a themed take-home bag. That is a complete lie. Parrots are not any of those. They might be fun-loving, but also kind of mean. They're very dirty. They're loud, and somewhat difficult to care for. But anyway, we don't tell the patrons that. Okay, so the scenario is, as I described, it's a slight modification, but we're doing the $5.01 Add a Parrot for a Penny special. And I switched it to five diners. If we do this in double math, this is in the download for the chapter as well, working with double. If I do this in double math, we'll get these results, and I'll explain them on the next slide. But we'll get the results we'll get at the console are going to say subtotal is 2505, which is 5 times 5.01, a discount of 250, subtotal after discount of 2254, gratuity of 451, total bill of 2705, and a three-way split of 902. And I did highlight some stuff here which might draw your attention to stuff that's maybe not entirely correct. But let's head to the next slide and look at it in more detail. So again, I tried to create an example here which would purposefully take advantage of some of Java's math issues. And I say that it's not really Java, right? It's binary math. It's base 10 math. It's the way microprocessors work. I have a tendency to kind of as shorthand say, Java's problems, but any programming language will have these issues. But what's wrong? I don't know what jumps out at you, but I highlighted two of the ones that I want to focus on, although most people seem to look at this three-way split and go, wait a minute, I can even tell it shouldn't be $9.02. If I multiply that back by 3, I don't get 2705. I get 2706. I'd be overpaying by a penny, and that's a problem, to some people. What I would say is actually that's not an error. That's this 2705 does not split three ways, right? So this is not a Java math or a binary math issue. It's actually just a check splitting complication in that we can't split that check three ways evenly. Somebody has to pay 901, and you can fight over who it is. Or if you all paid 902, you would be overpaying by a penny, which if you weren't so cheap, that wouldn't bother you. But a lot of people focus on that when that's actually not an issue. The issues are the ones that are highlighted. So, looking at the discount. If we took 10% of 2505, we would get 2.505. And most people would look at that and say, Well, that should round up to $2.51. The way we most often do rounding is you would round that up, and it doesn't appear to have done that. But then even worse, this is the big thing. Even without a calculator in hand, you can look at this and say, wait a minute, 2505 minus 250 can't be 2254, right? That's off by a penny. And the gratuity then also proceeds with that error. But then the bill total might be correct and the split is as correct as it can be. So, what on earth is going on? That's an actual series of double calculations using number format to format the results to present them nicely as money. And even doing all this, we get this weird inconsistency here. And this is not a number that's 15 places out. It's not a number after a whole string of zeros. It's actually a number that is showing up in the cents digits that you can see on the bill. So if you run this in Eclipse, it will run it and present the results, but it can also present these results unformatted. So here are the unformatted results. And you can see right off the bat, well, that subtotal, that 2505, isn't actually quite 2505. It's 25.049. And so that's why it rounded to 2505. The discount of 2505 then makes more sense because the number we were taking that 10% off of was not 2505, it was 25.049. But that also leaves us with this imprecise subtotal off by a tiny amount. Gratuity likewise has this bit of error in it. The bill split also slightly off, and the three-way split, well, it's as good as you're going to get, again, for reasons that actually don't have anything to do with the previous math. Really, it has to do with trying to split that number three ways, and it doesn't really split three ways. So lots of stuff going on. The discount of 2505 is a little bit perplexing, but you need to know that under the hood, I used number format to present the results, and number format by default uses half-even rounding. That's one of the reasons I introduced it earlier and have kind of pushed it, is that it does the rounding the way we want it to round money. But half-even is confusing to a lot of people. So 2.505, you have to decide, do I round up to 251 or down to 250? And half-even would round down to 0. 0 is even, you might remember. 1 is odd. So it won't round up because that would be 251 and 1 is odd. It's going to round, half-even will round down to 250. It's one of these things where even looking under the hood, it's not always perfectly clarifying because you see all these errors and then also the half-even rounding kicking in and also the three-way split issue kicking in, and you get this bill that's it should be really simple, right? I mean, this isn't all that complex. This is a restaurant check, and yet it gives you trouble. It gives us trouble. The total is correct. So in some ways in the bill, the inaccuracies have canceled each other out, and the three-way split is off by a tiny amount. It should be 9.018, would be perfectly accurate. But then again, as formatted, it looks right. And again, it's 902, which is a penny too much, but that has nothing to do with Java. So it might be surprising how easy then it is to create a restaurant check that will actually have multiple issues in it that are visible, that show up, that a customer who's paying attention will notice, that we obviously don't want in place. At the same time, I know some of you are saying, but come on, it's just a penny. It's a penny here, it's a penny there. But it's also the inconsistency in the check, right? The math doesn't add up in the check. It's off, and it's weird. But it's still just a penny in this case. And so another way to look at it, though, is what if these weren't mini pizzas? What if they were large numbers? Like the big European debt bailout a few years ago. bailing out, Greece and Italy and some of the countries that were really struggling with, huge multi-billion-dollar, trillion-dollar, payments. What if, as those were calculated, that some of these errors crept into the calculations, right? Then we might not be dealing with a penny. Maybe you'd end up dealing with a number that's quite a bit larger. Mistakes matter. There are entire websites set up to look at, to discuss, to analyze how software errors, machine errors, have caused significant damage. That is, I've got some of the big ones here, which is the Space Shuttle Endeavour nearly missed a rendezvous with a satellite, which was their mission to get to and fix. Because of a software glitch, a number glitch, a rounding error in the Patriot missile system caused it to miscalculate the time on an incoming missile, which then hit the Marine base and killed 28 soldiers. I mean, obviously you would say it was the missile's fault, but there is some culpability in that there was a software error in the Patriot missile system that did cause it to miscalculate and miss the incoming missile, which it should have hit. There are other examples of coding errors at banks. There was an issue in the news where the bank foreclosed on a woman because of a software error, because I think as it ended up, it found that she hadn't fully paid off the house. There was still a penny or some positive amount that was left over, and so they foreclosed on the house. And it was their error. And you might be saying, of course, banks don't need software errors to foreclose on people inappropriately. There have been examples where they've foreclosed on people who had no mortgage and sent the sheriff to kick them out of their home, and they certainly don't need to. There doesn't need to be software errors for, certainly malfeasance to happen. And it is, there's so many more examples. Obviously, this is kind of it is a science fiction trope, right? Machine errors killing people, damaging people, hurting people is the basis of lots of movies, but it actually does happen in real life. And I've got a list of more examples in the book on 437, and then I've got some links also to websites that look at this if it is, something that's interesting to you. But I do want to make the point, even though we're business programmers, and even though if we end up writing code, most of it will end up handling money amounts. That's not necessarily the case at all. I think it's a misconception. You may go into a firm that is coding stuff for, the Mars rover or industrial, mechanical processes of some sort, where your coding skills and your management skills of people doing the coding will come into play, and you need to know that these errors are real and are important and can in fact lead to, injury and death. That's a bit of a downer, but it is true, and it's our responsibility to face that, squarely and deal with it. Okay, not just Java. I think some of you probably, as you're reading the book or as you're listening to me, are thinking, why does Java have to be so complicated? I think that because that's probably a thought that I had when doing this, at how easy it was to get Java to mess up. I thought, why does Java have to be so complicated? As I said a few minutes ago, it's not necessarily Java. As shorthand, I say, why does Java have to be so complicated? But it's not really Java. That as an aside, one of the first thoughts I had was, well, I bet spreadsheets handle this correctly, right? We've all learned to use and rely on spreadsheets, and in fact, there are studies that say we may rely on spreadsheets too much to do math that's way too really complex for them. Well, whatever the case may be, people use spreadsheets. People like spreadsheets. Spreadsheets have utility. Spreadsheets in general are something that many people can learn to use and learn to use pretty well. My first thought was, I'm going to fire this up in Eclipse, not in Eclipse. I keep saying Eclipse when I mean Excel. I'm going to fire this up in Excel. I'm going to write this spreadsheet, and I'm going to see what we get. So this is what I got. And you'll notice in the results formatted as currency using Excel's own methods, own functions, I get this apparent error. So maybe you'll notice Excel has the discount as 251, which we know from looking at the numbers under the hood, it should not be. It did not use banker's rounding. It rounded up. It did half up. And then to make matters worse, when it took the discount off the subtotal, it's off by a penny. I mean, there's no way 2505, even if you can't do that in your head, there's no way 2505 minus 251, there's 2505, which is the subtotal, 251 is the discount. There's no way that can be 2255. It should be 2254, right? So we get the same end results, 2705 for the total and 902 for the split. So the spreadsheet, Excel, did not get it right. I'm not an expert Excel or spreadsheet user, and I'm not a spreadsheetist, but I do know that spreadsheets were designed to work with money amounts, and I looked and looked and looked and could not find a way to switch to banker's rounding. I tried to code it in myself with no luck. I tried different functions that were built into Excel that seemed like they might do the trick. I could not get one of them to do the trick. I Googled this. That said, I only spent a few hours doing it. I might be missing some way to do this, some way to get it to work. But I guess the point is, I'll bet most people don't do it correctly either. So, and just interesting on a whim, I tried it in Apple spreadsheet, which is numbers, which I really like. It actually did it correct, which floored me. The idea that, Apple's easy to use spreadsheet would somehow do this sophisticated bit of money handling correctly, whereas Excel would not, was a surprise. So, I mean, bottom line is, it actually is not just Java. If we are in charge of a software development project that specifically is dealing with handling money, then what are the ways in which we fix it? Most programmers just use double, which is what we've shown that they don't work great. Small errors can creep in. Small errors can work their way into results that you present to users. Small errors can be stored in databases and then aggregated with other small errors. So there's a caution to using doubles. So if you search, you will see there's two major solutions that there are proponents of. One is to use long integers. The other is to use something called BigDecimal. So long integers, just really briefly, there is some intuitive attraction to that. You know that you can use long integers or do integer math without any sort of decimal rounding issues because there are no decimal places, right? And you might say initially, well, wait a minute, how would you use integers? How would you then represent cents? Well, the proponents of using integers would say that 1 in an integer is 1 cent, or it's 1 mil, or whatever it is, depending on the context or the currency. So 1 long is not $1 or €1. It's 1 cent, say, if you do it that way. And there are absolutely supporters, and I have a kind of an in-depth analysis in the book. If you want to look through, we'll show you some of the pitfalls and results of using that approach. And in the end, I would say it's probably not the best approach. I'm not alone in that assessment. The other potential solution, though, is BigDecimal. I just want to give you a brief introduction to BigDecimal. If you ask Oracle, if you search online and say, what is the recommended way to handle money, math with money in Java, the answer is something called BigDecimal. BigDecimal is a class that stores floating point numbers and attempts to do so with perfect accuracy. Or when that isn't the case, it gives you full control over how precise you want to be and what rounding process you want to use. So you get to pick. It sounds wonderful, right? That first sentence is, if that was the sales blurb, you'd say, all right, I'm sold. I'll take BigDecimal. However, let me also tell you some of the downsides. it is, I say, somewhat more difficult to work with and a bit slower than previous approaches, and those might be understatements. Of course, a bit slower on a computer, you guys know, is still, in general, fairly quick. And it used to be when I started teaching this big decimal chapter, I don't know, 5 or 6 years ago, I added it. Certainly the computers in the classrooms at the time were a little bit old, and I would run some of these examples and there would be a noticeable lag. I'd hit run and then would all wait. And we weren't doing anything complex. I mean, I wasn't creating a bunch of pirate ships and trying to add them randomly to a grid and loading images and trying to assign images to these and all this kind of stuff that would eat up some time. I was just trying to do the restaurant check. And I would hit run and we'd all just wait 2 or 3 seconds, maybe for the results to pop up. Anyway, it's not really the case anymore. Like I said, those computers were at the end of their life cycle, and that was years ago at this point. So you may not notice any sort of a lag, which is awesome. How do we use Big Decimal? So Big Decimal is a class. I already said that. Capital B, capital D, Big Decimal. So we create Big Decimal objects, and we use the new instantiation syntax I've got right here to create our numbers. So to create the number 501 for our add a Parrot for a penny special, the syntax would be Big Decimal, say price, equals new Big Decimal, and then 501 in quotes. And then we're going to get to this next time, but we're going to set something called a MathContext, which tells Java, tells Big Decimal how precise you want to be, how much effort you want to go into representing Big Decimal numbers. And then we're going to use Big Decimal methods to do the math. So yeah, that's right. We cannot use the plus operator or the minus operator. When doing Big Decimal math, we have to use these built-in methods: add, subtract, multiply, divide, square root, remainder, power. So power is maybe the one thing that is easier to do in Big Decimal than it is to do with doubles, but everything else is harder. So next time we'll pick up the Big Decimal introduction, talk about math context a little bit, and then cover a couple of issues with Big Decimal, how to do the math, and then we'll dive into, okay, well then how do we do the math? How do we round stuff? What are the pros and cons? What are the techniques? What are the cautions? Because Big Decimal is not perfect. When I say difficult to work with, you've just seen a little bit of that difficulty in terms of we have to set the math context. We have to use all of these methods instead of actual math operators. And then the rounding is an issue that we'll have to deal with as well. All right, that's where I wanted to make it to today. We landed on Big Decimal, and we'll pick up here Thursday and work through how to do this restaurant check in Big Decimal instead of double.